the night skies have long evoked interminable requests concerning the presence of tenable planets and universes outside our own planetary gathering. Actually, NASA has spent serious billions of dollars unraveling these heavenly mysteries as the James Webb Space Telescope explores the profundities of space, searching for those reactions. In an astonishing new advancement, this noteworthy space telescope uncovered its most critical veritable pictures from a distant world, signifying a profound accomplishment. What is this recently found world beyond our planetary gathering, and what implications does it hold for our own planet? Come with us as we explore how the James Webb Telescope got the most astonishing picture ever found in history. The human story has consistently revolved around advancement. Our forerunners devised fire to fight the ruthless cold and pass down this knowledge to individuals and later generations. Driven by curiosity, they envisioned the wheel, made cultivating, and invented systems that dove into actual science and embarked on space examination. Throughout our history, advancements have risen and fallen, but we continue to improve and record our victories and disillusionments for future generations. When the Hubble Space Telescope revealed the transport of dark matter and galaxy clusters, it seemed like one of the greatest scientific discoveries. However, that wisdom changed when NASA, in a joint effort with the European Space Agency, ESA, and the Canadian Space Agency, CSA, launched an exceptional scientific instrument, a solid telescope designed to observe the evolution of galaxies, stars, and planetary systems. Soon after, analysts were both invigorated and shocked by its latest disclosures, particularly since it has received visual confirmation to support its findings. The James Webb Telescope, JWST, has captured the most terrifying picture ever tracked down in history, and together we will examine its implications for our planet and nearby planetary systems. But first, let us grasp the unparalleled uniqueness of this momentous telescope. The James Webb Telescope is no ordinary telescope, it stands as the largest and most advanced space telescope ever constructed, prepared to take humanity on a journey back to the early stages of the universe with forefront development. The JWST has the critical ability to peer back in time, getting glimpses of the universe as it existed billions of years ago. Its primary objective is to reveal the advanced insights of the universe by capturing images of the earliest systems that existed when the universe was a mere 200 million years old. After more than 30 years of organizing and development, the JWST was launched on December 25, 2021, aboard an Ariane 5 rocket, with a budget exceeding $10 billion. The launch of such a complicated instrument into space continually carries risks. This mission, however, vanished without any issues. After a long journey of nearly 1 million miles, the JWST arrived at its designated location in space, known as the second Lagrange point, L2. This point is generally 1.5 million kilometers from Earth and provides a stable gravitational environment arranged opposite the Sun, similar to Earth's orbit. This point has been chosen by various other space telescopes, including the Hubble Space Telescope, for their missions. The JWST has 4 main areas of focus. It aims to study the universe's earliest light, enabling us to investigate the formation of galaxies and stars in the early universe. It looks at the formation of stars and planetary systems, revealing insights into the processes that lead to these celestial bodies. It conducts a wide study of planets, including their potential to support life. These areas of study are critical for space exploration, yet they have been limited due to the challenges of observing distant space objects with precision. The JWST overcomes these obstacles, allowing us to delve deeper into the mysteries of the universe. Before the JWST could begin its boundless insights, it needed to undergo essential scientific and configuration tests. One of the most crucial steps involved deploying its immense sun shield, a 5-layered film carefully designed to protect the telescope's sensitive instruments from the sun's extreme heat and light. Considering that the telescope will traverse space indefinitely, the shield is essential for its protection. The deployment process required demanding thought and care to ensure that each layer was precisely tensioned and adjusted. Any misalignment or damage to the sun shield could have jeopardized the telescope's ability to observe distant objects. Fortunately, the deployment test was successful, paving the way for the next stages. Another essential test involved powering up the telescope's scientific instruments individually to check their functionality. These instruments include the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, each with its unique capabilities for studying the universe. This monumental endeavor involved the collaboration of more than 300 universities, institutions, and organizations from 29 U.S. states. Despite the challenges, the JWST made astounding progress, demonstrating its readiness for the exciting scientific exploration ahead. Once the JWST was in its assigned position, broad accessibility was critical to ensure its optimal performance. The telescope's primary mirror consists of 18 hexagonal segments that had to be precisely adjusted to produce a clear image. Setting up the telescope involved deploying the sun shield, expanding the support structure, and gradually deploying the primary mirror. The mirror required precise tuning to achieve the alignment necessary for consistent observations. In fact, even a small mistake in the process could have jeopardized the enormous investment of over $10 billion. Additionally, accurate pointing in global positioning systems were critical to ensure that the telescope could precisely point at and track objects in space. The process known as calibration involved making note of adjustments to targets and aligning the telescope systems to ensure exact focus on selected areas. All of these tests and procedures were crucial to guarantee that the JWST was functioning correctly and ready to embark on its primary mission of exploring the universe. The successful completion of these tests ignited excitement within the scientific community, while everyone anticipated smooth progress. However, things do not always go as planned. The way that the JWST completed all these challenges. Appraisals flawlessly were truly astonishing, making it a really global undertaking. In July 2022, following the completion of all evaluations coordinated by NASA, the James Webb Space Telescope, JWST, got approval to begin its mission. NASA declared that each of the 17 of the observatory's instrument modes had been fully investigated, and the JWST was ready to set out on its journey of discovery. What sets the JWST apart is its specialization in the infrared range. While our eyes can see visible light, the JWST works in the infrared range, which is like high-level night vision for the entire universe. Due to its significant size, the JWST can gather considerably more light than other telescopes, enabling us to see more distant and subtle objects. Being in space eliminates atmospheric interference, making the JWST an exceptional instrument for examining the universe. This is why it is often referred to as the eyes on the universe. As of now, this astounding instrument has captured the most detailed images ever found in history. What critical planning was behind this new revelation? Furthermore, what has the James Webb Space Telescope discovered so far? The JWST is a marvel of engineering, using remarkable innovations to achieve its spectacular results. At the center of its capabilities lies a colossal 20-foot mirror, meticulously designed to collect and reflect light to its array of instruments. Complementing this critical mirror are 4 specialized instruments, each carefully crafted to capture specific types of light and provide unique views of the vast universe. One of the JWST's main instruments is the near-infrared camera, NIRCam, responsible for capturing stunning images of nebulae, galaxies, and other celestial wonders in the near-infrared range. Working in tandem with NIRCam is the near-infrared spectrograph, NIR-SPEC, which analyzes incoming light and breaks it into its component colors. This capability allows scientists to uncover various insights about the objects under observation, making it particularly significant for studying their composition, formation, and physical properties. The mid-infrared instrument, MIRI, is another essential component of the JWST, designed to capture infrared light and investigate a wide range of cosmic phenomena, from studying the early universe to examining exoplanets in our own solar system. MIRI provides critical insights into the infrared range. Additionally, the Fine Guidance Sensor, FGS, is a vital component in the precise pointing and tracking of celestial objects sensitive to infrared light. FGS ensures that the telescope remains accurately aligned with its target objects in the vastness of space. Now you may ask why NASA chose to focus on infrared light, considering the various types of light available. The primary reason is that infrared light has longer wavelengths compared to visible light. Unfortunately, Earth's atmosphere blocks much of the infrared light from space, necessitating the use of a specialized telescope like the JWST to capture it. However, the deeper reason lies in the expansion of the universe. As the universe expands, the light emitted by objects in space undergoes a fascinating phenomenon known as redshift. This means that the light from these objects is stretched and shifted toward the red end of the spectrum as they move away from us. As objects continue to move farther away, their emitted light can shift into the infrared portion of the spectrum. This redshifted light allows us to peer back in time and observe the early universe, acting as a cosmic time machine that reveals how the universe appeared billions of years ago. The JWST's most significant scientific images, revealed by NASA in July, showcased stunning wonders like the Carina Nebula and the Southern Ring Nebula. These images demonstrated not only their visual grandeur but also provided valuable scientific insights. For instance, the view of Stephan's quintet offered new knowledge about the interactions between galaxies, while the analysis of the exoplanet WASP-96b contributed to our understanding of exoplanet evolution. In February 2022, the JWST captured its first images of starlight, including 18 distinct bright spots. Over time, these spots will gradually merge into a single star as the telescope refines its alignment and focus. This striking capability highlights the JWST's accuracy and precision regarding significant observations. We should delve into some of the key accomplishments and discoveries made by the JWST since its launch on February 18. NASA unveiled a revised and updated image of HD 8446, showcasing the developing capabilities and precision of the JWST. The initial 18 unfocused duplicates of the star were carefully arranged in a hexagonal pattern, providing a brief glimpse of what a final image would look like. By adjusting each segment of the primary mirror, scientists were able to stack these images and produce a sharp depiction of the star, offering a clearer view and emphasizing the telescope's remarkable accuracy and precision. The JWST also achieved a unique milestone by capturing a selfie using a specialized camera inside the NIRCam instrument. Initially intended for alignment and calibration purposes, this remarkable selfie featured one mirror segment shining more brightly than the rest, illustrating effective alignment. Over time, all mirror segments were adjusted, demonstrating the telescope's precision. Additionally, the JWST provided an unprecedented look at the Orion Nebula. Backbones of creation are known for their rising above sections of gas and buildup that stretch into space. In the most late pictures, the prominent places of support stand tall, uncovering a staggering scene of gigantic birth. Inside the support centers, different protostars emerge as moment red spots, showing the unfathomable powers at work in this great nursery. These photos offer a more significant understanding of the strong cycles that shape the universe. The high-level infrared imaging skills of the James Webb Space Telescope, JWST, have opened secret cycles inside grand plans, engaging us to explore hidden depths within the universe by utilizing a pet of indisputable assortments that fundamentally address devilish, substantial infrared frequencies. The JWST reveals capricious cycles and heavenly eccentricities, giving remarkable points of view on great contemplations. For example, the primary stages of creation. Despite these accomplishments, the JWST has been making gigantic progress in its coherent discernments. It has been taking into account an extent of brilliant articles, including worlds, nebulae, exoplanets, and our own planetary gathering. By seeing far-off universes, the telescope plans to uncover insights into the development and headway of galaxies through colossal history. It also explores the occupation of dark holes in universe formation and studies the components of universe bundles. The JWST's impressions of exoplanets have the likelihood to change how we could interpret these distant worlds. The telescope can analyze the conditions of exoplanets, giving comprehension into their construction and possible viability. By thinking about exoplanet environments, scientists aim to perceive signs of something happening under the surface or reasonable conditions on various planets. Additionally, the JWST has been imaging objects inside our own planetary gathering, including planets, moons, asteroids, and comets. These insights add, taking everything into account, to the close planetary system's course of action and headway, as well as providing distinct information about the creation and components of these heavenly bodies. Commonly, the James Webb Space Telescope tends to an extraordinary hop forward in our ability to research and handle the universe. Its high-level instruments and capabilities, combined with its abhorrence for infrared light, grant scientists to think on divine things and idiosyncrasies in remarkable detail. The telescope's responsibilities might reshape how we could interpret the universe, uncovering secrets of the early universe and providing pieces of information into the existence of life beyond Earth. How did the mission for viable exoplanets lead to the staggering discoveries? The journey for decent exoplanets has prompted a dazzling revelation that goes beyond conveying apparently amazing pictures. Direct imaging of exoplanets fills in as a basic endeavor to sort out planetary advancement processes and the manifestations of exoplanetary conditions. This assessment holds the possibility to recognize exoplanets with conditions accommodating for viability. Fortunately, the capabilities of the James Webb Space Telescope, JWST, bring us closer to this goal. By seeing the most settled universes, the JWST has achieved another remarkable achievement. These enormous systems began when the universe was in its beginning phases, just 2% of its ongoing age, and are tracked down around 13.4 billion light-years from Earth. They hold the record for being the most distant ever. This achievement allows specialists to concentrate on early cosmic history and provides insights into the universe's formation. Focusing on galaxies that are more than 13 billion years old is an incredible task due to their gigantic distance. Specialists needed to meticulously perceive and analyze these obsolete universes using refined techniques and detailed insights. The JWST's capabilities played a fundamental role in making this essential discernment possible. Its achievements in direct exoplanet imaging and the observation of ancient galaxies highlight its noteworthy impact on how we could interpret the universe. The JWST continues to push the boundaries of what is possible in the field of astronomy, offering new perspectives on the universe's underlying history and the potential for life beyond our planetary gathering. The James Webb Space Telescope, or JWST, is undoubtedly an imperative instrument that promises to change how we could decipher the universe in various ways. Now, let us shift our focus to the captivating new world, the ghostly infinite system. Despite its dangerous nature in the night sky, this world reveals its resplendent wonder when captured by the JWST's infrared camera. The universe known as M74 honors us with a staggering show of its perfect winding shape, with stars dissipating from the brilliant center. Arms stretch outward, delivering a limitless weaving that paints the sky. While the optical view of the phantom world, as captured by the Hubble Space Telescope, grandstands its sublime marvel, it also reveals structures resembling fibers of force transmitting buildup and gas oozing from a brilliant focus, all washed in a striking electric blue color. Conversely, the JWST's image gives a clever impression into the infinite system's secret corners, enlightening star-forming regions scattered throughout the twisting arms through its amazing infrared limits. In an uncommon achievement, researchers have combined photographs from both the Hubble Space Telescope and the James Webb Space Telescope to create a composite picture that transcends the limitations of optical and infrared perspectives. This stunning composite offers a more complete understanding of the inestimable framework, enhancing our knowledge of its complex features. As part of an overall project, these 3 photographs were prominently featured in a film, impacting specialists to contrast and examine them one next to the other. Through this critical collaboration, cosmologists have had the opportunity to perceive areas where stars are currently being born, as well as gain precise assessments related to the larger number and seasons of star bundles. Moreover, JWST studies have yielded precious insights into the qualities of moment buildup particles, exploring the vast domain of interstellar space.